Hello, this lesson is a continuation of the last lesson. This is part 4. Part 4. This is the question. Integrate this function. Because we use partial fraction, we expand this into two fractions. One thing we need to pay attention to. The denominator is the square of the bracket. When we expand into partial fraction, we need to write two denominators. One is the original denominator. Another one we use exponent 1. This is how you write the partial fraction. And A and B are two constants to be determined. Expand this using common denominator. So A is multiplied the bracket x plus 2. You already have x plus 2, but the common denominator is x plus 2 squared. So A times x plus 2. B is just itself. So the numerator of this part is A times x plus 2 plus B. That's the numerator here. Then this numerator must equal to this numerator. So I have this equals that. Expand, I have ax plus 2a plus b. This term corresponds to this term. This term corresponds to this term. I mean, these two terms together should be this. So I have two relations, two equations with two unknowns A and B. I can solve for A and B, and the result is A equals 6, B equals -5. Now I put 6 here and -5 here. I separate the integration into two integrations. The integration this part and integration this part. Two integrations. This part, the result of integration is a logarithm function. 6 is a constant. So this is the result of integration. This is just the absolute value. Okay. The integration of this is this. And you add a constant of integration. So this is the result. Another example here. So expand this into partial fractions. This is the denominator. Now this denominator goes to exponent 2. And like this example, exponent 2 here, I need to write exponent 1 and also exponent 2. The denominator of this part is degree 2. So the numerator, we need to write a degree 1 polynomial. So the numerator is ax plus b. This is degree 1, so you just have a constant. This is degree 1. You don't look at this square, so look at this bracket. The degree is 1, so there is only a constant. Common denominator. Common denominator is this bracket times this bracket. And once you do common denominator, what is the numerator? The numerator is this times this. Ax plus b multiply x minus 1 squared. For this part, the numerator becomes x minus 1 because you only have power 1, but the common denominator has power 2, therefore you must multiply x minus 1 and multiply this. For this part, the numerator becomes just d times this. So this is the numerator, and it must equal to the numerator here. So this is equal to that. Expand, collect terms. I have x squared term. Oh, no, not x squared. Here is x squared, and here is another x, so it's x cubed. X cubed term, x squared term, and x term, and constant. So let's compare the left side with the right hand side. I have this a plus c is 0. I have this, the coefficient of square term is also 0. There is no square term here on the left hand side. So this is equal to 0, and this should equal to this, and this should equal to this. So I have 4 equations. How many unknowns? I have 4 unknowns here. A, B, C, D. I have 4 unknowns. So 4 equations, 4 unknowns. I can solve. This is the result. A is 2, B is 1, C is negative 2, D is 1. Put the results into here. A, B, C, D. I have integration, integration, integration. So I have integration, integration, integration. I separate this into 2 integrations. The first integration is just 2x. The second integration is this 1. So I have this, and I just copy this, and then I can do the integration. The integration of this is a log function. The integration of this is arctangent, and the integration of this is log. Integration of this is just this function. So this is the result, final result, with a constant of integration. So this is just about all I like to mention partial fraction method to integrate. Good. This is the end of this lesson. I'll see you next time. Goodbye.